Hello everybody, in today's video we're going to be going over an upcoming cold and snowy pattern for portions of the eastern United States. This is going to be mainly taking into effect of what's going to happen in early and mid-January and potentially what's even going to happen into later January and into February. We have a very favorable pattern for some cold and snow into the eastern United States. Now, quick disclaimer, I'm actually recording this on the morning of the 24th, so some of this information by when you're watching this video might be about 24 hours old or so. All the links that I use are down in the description, and they will have all the updated information, so you can check those out if you want to see all the updated maps. But I'm only doing that mainly because I want to be spending Christmas with my family on Christmas morning, so I won't really be able to upload then. So I want to get an upload done right now so that I can have that uploaded for you guys on Christmas, so you guys still have a video while I'm spending time with my family. So also, one thing, the long range really doesn't change day to day too much. It really is more of a trend of what's happening, and so it's not going to really change. Don't expect this to change too much even by tomorrow or even by mid next week. This is really a longer term thing. It takes a lot longer for patterns to break down than it does for storm systems to move through. So really, it doesn't really matter what each individual run does, because most of the runs are going to be quite similar to each other, especially when you're looking at upper air maps and also in the longer term. So here's what the current GFS model is showing, and let's start talking about what your upper atmosphere is looking like and where your ridges are going to be, where your troughs are going to be, and where that polar vortex is going to be. So what we're dealing with here is your 10 millibar height, which is basically about 95,000 to 110,000 or so feet up in the atmosphere, and that is going to take a while for this to translate down. So here's your air mass, for example, up 95,000 to 110,000 feet up. That's going to take a while to get down to the surface, where you have to get down 90,000 feet or so. So that is going to take a while, and usually it does take about 7 to 10 days for that cold air or that warm air, whatever type of atmosphere is above you, to actually make it down to the surface. So this is about a 7 to 10 day lagging indicator. For example, this would be right now for the 24th. This is what the current upper air map looks like. And we're dealing with this probably happening in real life down to the surface right around the 31st to about the 2nd of January. So it is a bit of a lagging indicator. Now, two things I want you guys to pay attention to is these two areas. One is going to be over Europe right here, where you're going to actually deal with some warming of and some very warm air that's going to move through the area. And then also, I want you guys to look at this area with the polar vortex, which is going to be right here, because you might actually get a split of the polar vortex according to what this model is showing. And the GFS model in the upper atmosphere has actually been quite accurate this year. So here would be by the 27th, and we're looking at a lot of that warm air really taking place, and this is what it looks like at the upper parts of the atmosphere by the 27th. But again, this is probably around January 2nd to about January 5th at the surface of when this will likely be taking place. So we see a developed ridge over Alaska, and actually western Alaska into easternmost Russia, and then we're also dealing with some more warm air over portions of southern and central Europe. Now, we also see that polar vortex moving through portions of the Arctic Circle, and that is eventually going to spill down into the eastern United States, and technically it is already into the eastern United States. Now, here would be by the 30th, and we're dealing with a lot of that warm air moving into portions of China, Mongolia, and then into portions of Central and Western Asia there, where you are dealing with some more of that warmer air. And then we're dealing with that polar vortex not being able to move into Europe, because it would like to move into Europe, but it wants to choose the path of least resistance, which would be, in this case, North America, because there isn't any ridging, there's only troughing, and ridging is very, very hard to break down. It takes a very long time to actually break down those ridges, but with troughs, you're just looking at a couple troughs moving in and out every week, so they are very, very movable. You can really, the polar vortex really does like troughing a lot more than it does like ridging, and because we have so much ridging over Europe, the only path for it to take, we have ridging also out over the Atlantic. The only path is to go southwestward into portions of the United States and into Canada. So As we continue this forward, you start to see that by January 2nd and by January 5th, we're looking at a much more dynamic pattern where we have a big trough into the eastern United States, a big dip in the jet stream into the eastern United States with a ridge over Alaska generally and the surrounding areas, and then we have some more warm air on either side of this trough. Now, something that's very important that you want to pay attention to is that we're dealing with two different polar vortexes splitting right here. We have one over over I guess eastern Canada, and then also one over about Finland and Sweden in that area. So we have two different polar vortexes, and that one's going to move further into Europe. This one's going to move further into North America, and when that happens, you actually get very, very cold air. And the last time a polar vortex actually split like this was probably back 3 or 4 or maybe even 5 years ago. So definitely it was a long time before we've seen our last split in a polar vortex like what we're seeing right now. And as we continue forward, you start to see that by January 7th, which is one of the last frames on this model run, we're looking at that polar vortex really getting a lot more defined, where you're looking at actually a much more defined, a much more closed in polar vortex, and that's going to allow even colder temperatures. You're seeing that ridging all throughout the western United States, and then again that troughing down through the eastern United States. So that's going to allow that cold air to really plunge fairly far to the south. And if you like cold and snow, this is definitely a very, very good sign for you guys. And then the last run, the last frame of the model run is showing that cold air dipping even further to the south. Here's the climate forecasting system, which usually has a very, very warm bias. But what we're seeing is that on the surface, while it does have a very warm bias, in the upper parts of the atmosphere, it's actually representing what the GFS is showing quite well, which I found very interesting. I would think that it would be more of a ridging pattern because of how warm biased this model is, but when you actually do look at the 10 millibar heights for this, you are looking at what the GFS was showing, where you have that ridge or that troughing down into the eastern United States and over eastern Canada, and then that ridging up through portions of the western part of North America and into Alaska there. And we also have more of that warmer air and what we would call a stratospheric warming event over portions of Europe and Asia. So that is definitely a very favorable pattern, again, if you do like cold and snow. So that would be for the entire month of January averaged out. For February, it is still cold, although that polar vortex, according to this model, does retreat a little bit. We'll still have to see if that is true, and we'll have to get within that about 15-day period of that actually happening to actually know if that is likely, or if the CFS model is just showing more of its warmer bias. Now, here is another factor that we have to look at. These are the oscillations, which is basically tracking different geographical areas and tracking how far away from normal their upper air temperatures are. And this is the AO, so this is the Arctic Oscillation, which of course you can guess is over the Arctic Circle. And this is again over Greenland and over northern Canada and again over that Arctic Circle. And it's tracking where are those, if it's colder or if it's warmer to normal. So we're seeing that we have right now, this is the blue line is where we were or where we are right now, and this is basically where we are right now. It's actually over a warming phase, and you can actually correlate that directly to different storm systems. This is the system that's happening right here. That big rise is actually that system happening right now, and then it's going to dip back down because that system leaves in some very cold air on the backside. And then when you see that rise, we're actually forecasting some sort of storm around the 28th or 29th, and then when it dips back down, be careful for another storm around this period from the 1st of January to about the 7th, because that could definitely be a possibility. But the bigger thing that I want to pay attention to is how far below normal does that get, and right now it's looking very below normal, 5 standard deviations below normal, which is extremely, pretty much off the chart below normal, and it's very, very rare to see that below normal of an Arctic oscillation, although we do have that. We have a very negative AO, which is actually very good if you do like cold and snow in the east. Now, here's what the EPO is showing. Usually you want this to either hover around neutral. If you hover it around neutral, it'll still be favorable or semi-conducive for some cold air into the eastern United States or over the United States in general. And we're looking at that still staying within about a degree or so of normal, or one standard deviation of normal. Here would be the NAO, which also you want to be negative, and you can see how negative that really does get. -3 on here, so this is a very good sign if you do like the cold, if you do like cold and snow, and you can see how it really just plummets. But then what you're also not seeing on this model is no upward direction on the last days of the model run, which you usually see. It's just a plateau. So what you're seeing is potentially this NAO staying fairly negative for at least a while, and staying. I don't really see any signs that it's going back near positive anytime soon. It might dip positive a little bit as we get closer to the 26th or 27th, but then it should skyrocket or actually plummet back further down, and maybe get close to -2 or -3 or 3 standard deviations below normal. So here's the PNA, and you want this to be positive, and it is positive. It has no signs of really going back negative, and when this does go negative, that can really override anything. But right now, if it's near neutral or it's even above normal, that's fairly good for a cold and snow in the eastern United States. And to kind of break down where all of these regions that we're talking about are located, the AO is over the Arctic Circle in that purple. The NAO is south of Greenland. The PNA is over the western part of North America. So again, when you see that positive, that usually means ridging. And of course, if you like cold and snow in the east, you know that you need to have ridging out over the west. And then that EPO, which is out south of Alaska, there, that can also be a big player into this pattern. Now, here's what you want if you want cold and snow in the east: negative AO, negative NAO, positive PNA, positive EPO, and actually all of those match up right now, and that's actually something that we haven't seen in probably 2 or 3 or even more years, and I can't really remember the last time where we're dealing with some sort of big polar vortex dip where you actually have it split. Sometimes it dips down into the US, but I can't remember the last time it actually split in two, which is very rare. And then here's what you want if you want cold and snow in the western United States: positive EPO, negative PNA, positive AO, and positive NAO if you do like cold and snow in the eastern United States or in the western United States there. So here's another factor that we have to talk about, and this is actually the MJO, the Madden-Julian Oscillation, which covers an area over the Indian Ocean, and it basically tracks where those air masses are, and each phase has a different effect on the United States. For example, phase 8, 1, and 2 are actually fairly cold, and usually they are regarded as the coldest phases, and then 7 can be colder. It is sometimes a little bit warmer, however, and then 6, 5, 4, 3, those are usually the colder, the warmer ones over the eastern United States, and actually the United States as a whole. So these yellow lines are actually where all the model members are. The purple is what it went through in November. The red is what it went through in December. So it was actually in a fairly warmer phase, or it was actually right around neutral. And then in the green, that's what is forecasted, and it's forecasted to stay neutral. And if it just stays neutral, that really doesn't have too much of an effect on our pattern, and that's actually a good thing, because our pattern right now is cold and snowy. So if you like that cold and snow, then you would want this to stay either near neutral, or maybe even make a visit to phases 8, 1, or 2. And as we continue this forward, here to be what that really means. And again, it's an area over the Indian Ocean and over the Pacific Ocean, tracking where that air mass is. So for example, in phase 2, the colder air mass is further to the west, but then you can see with each phase, it really does move further and further to the east, and that's going to have an effect on the pattern of the eastern United States and the United States as a whole as you go through time, especially with that MJO. It can be very influential into the pattern. Now, here's what each phase really means, and you can see on the left-hand side, that's where you're looking at your actual temperature anomalies by each phase. So you can see how phase 1 and 2 are actually fairly cold, and then also for phase 8, it's fairly cold. Phase 7, 6, 5, 3 can actually be fairly neutral, and then phase 4 is also fairly warm for much of the east. And then if you like cold and snow in the west, you want you would want maybe phase 8 is okay, but you would really want phase 7, 3, or 6, or maybe even 5, where you actually get that cold air into the southwestern and the western United States as a whole. So that is going to wrap it up for today's video. Hopefully it wasn't too much of an inconvenience that this information is slightly outdated. It's not going to really make too much of a difference because, again, the long range isn't as fickle as some of the shorter term indications. So, for example, we're not talking about specific storm systems. We're talking about a big polar vortex that's much easier to track than what we're dealing with, like, for example, individual storms. It's much easier to actually forecast this type of stuff, the longer range, especially when you're only 15 to 30 days out. So don't expect this information to change too much, although it is a possibility, and you definitely want to keep an eye on that. And again, all the links are posted down below, so if you want to double check this information for yourself, definitely go down below in the description, and I have all those links posted with the most up-to-date information of where I got all these maps and where I got all this information. So that is going to wrap it up for today's video. Please consider liking the video, subscribing, and turning on notifications, and I'll see you guys in the next video. Goodbye.